You might have seen plants grown on the ISS, or scientists talk about their work in a field called astroagriculture. If you haven't, don't worry. Astroagriculture, or astrobotany, is a relatively new field which has grown in the past 20 years. Even if you have heard of it before, you might not know its purpose, or even what scientists in that field do. So buckle your seatbelts, we're about to take off. The idea of growing plants in space was first created by Russian rocket scientist Konstantin Eduardovich Tsiolkovsky in 1895. Tsiolkovsky theorized that plants could be grown in space, in isolated orbital greenhouses where humans provide carbon dioxide and plants provide oxygen. Throughout the mid-1900s, NASA and the Soviet Union experimented with sending plants in space. In 1975, astronauts aboard the Soviet Salyut 4 were the first ever to eat crops they had grown in a spacecraft. This monumental achievement was followed by efforts to create inventions which supported spaceplant growth, such as the Svet-2SG plant growth system, which was a collaboration between Russia, Bulgaria, and the US. But during the 2010s, astroagriculture started to claim more attention, and more people realized the value of growing a fresh food source in space. If spacecrafts could provide food independently, restocking time could be used for more exploration. Fresh food produce also has more nutritional value than the freeze-dried or thermostabilized food that astronauts currently eat. Furthermore, fresh food has physiological benefits. Astronauts who are able to see plants and take care of them will have a piece of home to de-stress amidst their extremely isolated and stressful jobs. Let's take a closer look at how plants are grown in space. Currently, scientists utilize two types of growth methods for space crops: hydroponics and in-soil growth. Hydroponics use nutrient-enriched water instead of soil to grow plants. These systems are helpful as they use far less water than crops grown in soil, but also weigh less and take up less space, a characteristic which makes them ideal in an environment with strict weight and volume restrictions. On the other hand, soil also has its advantages. Soil can be used for a long period of time, while hydroponics are usually only used for short-term crops, such as leafy greens. This is because hydroponics can be susceptible to waterborne diseases or mold. But the soil that astroagriculturalists use is not just soil from Earth, but regolith. The word regolith means the layer of loose rock and dust that sits on the surface of many planets, including our neighbor, Mars. A hot topic in the astrobotany world is using other planets' soil to grow crops. Successfully growing plants in soil from other planets would help save time and materials for future space missions. One type of regolith that is most heavily tested is Martian regolith. Martian regolith is a sandy material that is high in silicates but also high in toxic perchlorate salts. While perchlorates can be found in small quantities in the natural world and sometimes even man-made inventions, such as rockets or fireworks, increased exposure to perchlorates can be harmful to humans and plants. For humans, perchlorate ingestion or inhalation can inhibit thyroid hormone production, impacting many essential bodily functions. For plants, large amounts of perchlorates can inhibit healthy growth. This can cause damage to leaves or roots, as perchlorate-rich soil can start to cement when given water. But never fear. Right now, scientists are looking at ways that perchlorates can be removed from Martian regolith. This can look like washing perchlorates out with water or using a special bacteria which eats the harmful compound. There is so much potential for the field of astrobotany. With the power to grow our own food on a spacecraft or on the surface of other planets, we can have the freedom to discover even more about the universe that we live in. While we might not have the solutions to all our problems now, remember that our progress started from a vision to grow plants in space. How happy would Tsiolkovsky be to find out that his vision is almost a reality?